Good morning from Hamburg. Welcome today to this little video where I would like to take the chance to demonstrate to you my little friend, the K20. Today we will do a quick overview about the measurements we can perform with this device. We will do surface tension measurements with both plate and the ring. We will do an interfacial tension measurement, and I will also show you how you can determine the density with this device. The K20 is our semi-automatic force tensiometer that can be run independently without a computer. It also contains an internal battery, meaning you can, for a certain amount of time, run it off of the electrical supply. And it's therefore a very versatile device that you can also use to some extent in a mobile way by placing it in different positions without worrying, for example, about the connection to a computer. I have already turned on the device so that we can start right away. You can have a look here at the display. This is the main control station of the device where you can do pretty much everything. You can see the different methods we can do. We can do the plate measurement, the ring measurement, the tear-off measurement, which is another version of the ring measurement, just with the lamellar tearing off instead of doing a multiple determination. We can do the density measurements, and we can change several things about the set. Okay. Now let's pretty much do the same thing with the ring method. The ring method now is a little more complicated in terms of setting it up, because with the ring method you need to know the density of your liquid. As we are using pure water here, 1 is fine. We go a little below because we are at 25 degrees, so we have something like 0.998. Okay. And also with the ring method, I will show you the ring real quick. With the ring method, as we are pulling it out of the liquid with this ring, so we're moving it up and down, we are pulling the water with us, and there will be some water under the ring that will also put a force onto the balance. And this we have to calculate out. This is where these correction factors, you can see here, correction, come into play. So you can click here, and there you can see different options. Harkins and Jordan is normally the most used correction factor. You can also find Nouy, and Waters in some other publication and norms as well. In some older devices, you had a special mode of performing the measurement without a correction factor. There you had it called ring measurement for no correction factor and ring C measurement with a correction factor. Here with the K20 we have it all in one menu, and you can simply select which of these correction factors you want or want not to use. Okay. We stay with Harkins and Jordan here for this measurement. And now we set up everything in the same way as we have done before. So I take down our plate again. Don't need it for now. Of course, all the rings and plates always come in these nice wooden boxes for you to store them safely at any time. And now we use the ring. And of course, with the ring, we have to do the same procedure. We have to activate it real quick by using our flame. Normally with the ring it's very quick, as we saw. We don't need to do it for too long. Just quickly making it glow for a moment is more than sufficient, so not too much work to do. We put the ring on here, as careful as possible to let it not swing too much. I am not the most skilled person in terms of having very calm hands, but even then it's working nicely. So we close it again. And here we now go a little bit differently. So each method, either plate or ring, is conducted a little bit differently. We bring up the surface of the liquid again very close to the liquid. Just something like this. Now once again we have to tear, because we are once again using our force-based measurement type. So we tear our balance to 0. And what we do now is we simply immerse the ring slightly inside the liquid, like around 1 millimeter. I hope you can see it here nicely. We just bring it inside so that the ring is fully covered inside the liquid. This is now already enough. And now what the device will do, it will pull out the ring out of the liquid and create a lamella like this. So what we simply do is we press on Start on the screen. Very simple. Now let's have a look at what's happening. And now let's have a look at the sample. You can see the ring is getting pulled out, ever so slowly. So the device is simply measuring the force that is put on the balance by the ring and the water that is pulled out, and is trying to find the maximum force. You pretty much probably know this measurement principle, so he pulls it out, finds the force maximum, then goes in again to repeat the measurement. We will not do it the full 10 times here, because the ring measurement takes much longer compared to the plate measurement. This is also one of the reasons why we from Chris normally recommend you to actually do the plate measurement whenever you can, because the plate is a static measurement and a much more simple measurement because it is performed much, much faster. So now our first value is taken. So now the sample stage goes up again, immersing the ring inside the liquid again to perform the same procedure of pulling the ring out and finding the maximum once more. Let's take 1 second value for you to see, and then we can already move on, because nothing more will happen here. So this measurement, the ring, is the older measurement type. It has been established in the literature way before the plate measurement. This is why you can find this measurement type in a lot of norms. For example, when you go into transformer oil measurements, the typical norms are all relying on the ring method. But for most uses, we actually recommend the plate because it is easier to use. Measurements are much faster, and as you do not have this up and down of the sample stage, you have a truly static measurement as well. So in most cases, go for the plate, our recommendation. But of course, you can also use the ring as well. And in some kinds of norms or publications, you will maybe be forced to use the ring. But this obviously depends on your application, and it's your choice in the end to do. I'm of course happy to provide you with a comparison between ring and plate measurement, but you will also find it in our manual. Okay, let's abort our measurements here. You can see nice, homogeneously equal results. So we're happy with this as well. So we stop it here now, because otherwise we would take a very, very long time. And this is how you do the ring measurement.